Okay, this next section is graphs, functions, and sequences continued. For 44, 45, and 46, we're matching up those described situations with the 4 different cars and the information that's given to us in the table. So for 44, it says Sonny's car sits stopped at the line at the begin as he begins the race. So stopped means it's going to be 0 miles per hour. So we should know right away that the first at 4:59 it's going to be 0 miles per hour. He accelerates quickly and stays steady. Then he sees something in the way of his car and slams on his brakes. So slams means he stops very, very quickly. He quickly comes to a stop. Which car in the table is Sonny's? So we know from the very beginning that it should start with 0. So we know it can't be car 2 or car 4. He speeds up quickly and stays steady. So if we're looking at 1 and 3, speeds up quickly from 0 to 65, 0 to 74. Those are both really quickly. And then stays steady. Now car 1 goes 65 to 80 to 50. That's not steady. But car 3 goes 74 to 74. So he's staying at that 74 miles per hour. So automatically we should know that for 44 it should be car 3. Now the next situation in 45 says Carl's race car rolls slowly onto the track and quickly accelerates. He remains at a constant speed throughout the race. So which car on the table is Carl's? So it rolls slowly onto the track. So that means it should be pretty slow. So we know it's not car 1 or car 3 because those are both completely stopped at the beginning of the track. So slowly, I think 10 miles per hour, a lot slower than 60 miles per hour. Now he remains at a constant speed throughout the race. So if I'm looking at car 2, I want to make sure this is correct. So constant speed, 60 miles per hour, 60 miles per hour, 60, 60. So I think that's pretty much a giveaway that this should be car 2. Now our last situation we know should either be car 1 or car 4 if we did the first 2 correctly, which I'm sure we did. So number 46, Dan's race car moves quickly to begin, speeds up more, so I'm going to underline speeds up more, to reach his top speed quickly. He remains that pace throughout most of the race. Which car in the table is Dan's? So I'm going to look at either car 1 or car 4. So let's look at car 1 or car 4. The beginning says moves quickly to begin. Well, in the very beginning, either car 1 is 0. Car 4 is 60. So even just with that first check, we should see that this is car 4. But I'm going to make sure, double check. He reaches his top speed quickly, so 60 to 74, 75. And he remains that pace throughout most of the race. So 74 and 75 miles per hour, 1 mile per hour difference is not very, can't really tell. So it's pretty much the similar. So we should think car 4 matches 46. The next 4 are asking us to draw a graph to represent the race car speeds above. Now we don't have a lot of room on this packet, and this looks similar to one of our review packets before one of our exams. So what I did was I already drew race car speeds for this one right here. So just look to the left on this part of the screen. I'm going to be using this one. The one on the right is what I'm going to use for number 51. But what I'm going to do is make 4 graphs that represent these 4 car speeds on this same graph. I'm just going to use different colors to determine which one's which. So the first one for car 1, I'm going to use black. So what I do is on my x-axis, I did time 4:59, 5, 5:01, 5:2, 5:3, so I made sure to label. I also labeled my y-axis with speed miles per hour, and each dash stands for 10 miles per hour. So this is when we're looking at a graph, this is just the first quadrant because both time and speed cannot be negative. So we know automatically we don't have to draw all 4 quadrants, we only have to draw this first quadrant. And making sure we pick an appropriate label and what to go by on each axis is very important. So since we only, our highest miles per hour is about 75, every dash being 10 is pretty reasonable. So for car 1, I'm going to make sure I'm using black for this. At 4:59, car 1 was at 0, so I'm going to put a dot there. At 5, it was at 65, so it should be around here. 5:01, it was 80. Put a dot right there. 5:02 was 50. And 5:03 was back to 0. So what I'm going to do is connect these dots as straight as I can. You don't have to be perfect. It's hard on this program. It's going to be hard on your own packet. For car number 2, I'm going to do red. So I'm going to circle 48 with red so we can tell the difference here. So for car 2 at 4:59, it's at 10. 5, it's at 60. 501 is at 60. 502 is at 60, and 503 is at 60. So that was the very constant speed. For car number 3, I'm going to be using blue here. So car 3 starts just like car 1 at 0, goes really quickly up to 74, and stays at 74 there. Again, very close to car number 1. 502 should be at 3, so it drops drastically down to here, and 503 is at 0. So I'm going to connect these dots as well. So they're all, at certain points, they kind of all overlap. That's fine. Now, for car 4, I'm going to be using green. Car 4 starts at 60, so it's out of the gate really quick. Next one's about 74, just like our blue car, or car number 3. Then to 75, again very similar. 74, and that should be a little bit more to the right. 502, 74, and 503, 74. And there we go. That's about those 4 cars graphed on the exact same graph. On your test, it'll tell you to graph them on separate ones. If that's on there, it'll be a little bit more specific, and we'll have a lot more room, don't worry. Number 51 says create a graph on graph paper that illustrates the information in the table about the number of lunches served in the cafeteria for the past week. Now over here, I've already written numbers of lunch served, so I put a title there just like you did above. I put race car speeds on the one to the left. I labeled my X and Y axis, my X axis as days, my Y axis as number of lunches. I used a little break here. You guys learned about that in science, so I didn't have to start at 0. I could just start at 350. So each dash goes up by 25 lunches. So on day 1, the number of lunches served was 585. About right there. Day 2 was 550. Day 3, 400. Day 4, 359. Right there. Day 5, 428. Day 6, 501. And day 7, 468. So let's see right there. And I'm going to connect again all of these dots in order. So we see the fluctuation of the amount of lunches served each day in this cafeteria. But make sure we pick appropriate units to go by. Make sure we're labeling everything very nice and clear, so if someone was just looking at this graph, they know exactly what you were graphing. Now with the above 2 graphs, I was able to label very clearly because I was given some sort of context. Now in 52 it says use the table to make a graph on attached graph paper, which again this isn't attached, we're just going to draw it on our packet, and write an equation on the line. So what we want to do is we want to make sure we have an equation. There should be a line that has equation, or at least equation with a colon there. It might be on the next page. It sure is. I'm going to move down a little bit so we can see that. So we're going to write our equation here once we create that equation. And I'm going to graph right here. There's just enough room. So I can't really label my X and Y axis with any units or anything because I'm not given any. So I can't really make anything up. So I just label my X axis 0 through 4. And my Y, my dash marks go by 5. So I could fit all the way up since my highest number is 29. It's always smart to look at your highest number to see how high you have to go, and then you can kind of judge from there how much you want to go by for each dash mark. So when X is 0, Y is 1, so it's going to be really low here. When X is 1, Y is 8, so it's a little under 10. When X is 2, Y is 15. When X is 3, Y is 22. And when X is 4, Y is 29. So I'm going to attach those and put little arrows there because that can continue on since this is an equation, or this is some sort of function, so we could write an equation that would continue on there. This is just what we were given. So that's my graph there. Now I'm going to look at my table here and try and figure out how to write my equation. So I know my equation should always start with, hopefully we're thinking y equals. That's how we're always going to start all of our equations. Now I'm going to look at the change in y. So from 1 to 8, well, that's plus 7. From 8 to 15, that's also plus 7. And it continues for each y. Consistent, each constant y. It's going up by 7. So since that's that constant change of 7, we know that that is our slope. So we can connect that 7x. It's always y equals mx plus b. That's slope-intercept form. So this is our slope, the m's our slope, and the b's our y-intercept. So we don't know, we do know what our y-intercept is, because when our x is 0, that's what our y-intercept should be. So when our x is 0, our y is 1. It gives it to us right there. So it's going to be a plus 1. It's a positive 1 there. So our equation should be y equals 7x plus 1. Now we may think we're correct, but in order to check, there's one way we can check, and we talked about it in class a couple times. We can take some of these points, plug in what we know for our x and our y, and make sure this equation's equal. So let's say we take 1 and 8. So we plug in 1 for x, so 7 times 1 is 7, plus 1 is 8, and y should be 8. So if we continue on and check those answers, those should all be right. So that's an easy way to make sure we got the right equation there.